Hello, good evening everyone. I hope all are doing well. Hi Anil, good evening. Okay, anyway, warm welcome all of you to the YouTube channel of Infinity Learned by Sri Chaitanya. This is me Surya, your chemistry faculty for this particular session. Today in this session we are going to the third part of our chapter, Redox Reaction. This is the most important topic. We are going to do the balancing of redox reaction here. Without wasting any time, I will directly go to the topic, that is balancing of redox reaction. I can guarantee that this is the most important topic from this chapter because you can see that more frequently questions are came from the same topic. So if you keep all attention here, you will get the maximum marks in the JEE Main exam from this particular chapter or the topic. Okay, here you can see that there are two methods for balancing the redox reaction. The first one is the oxidation number method and the second one is the half reaction method. Let us start with the first method, that is oxidation number method. What do you mean by the oxidation number method? Okay, there are several rules to find out the balancing of redox reaction. We can see one by one with an example. The first rule about the oxidation number method is that first you have to write the skeletal equation. You have to write the skeletal equation representing the redox reaction. As you can see here, I have given an example here, that is MnO4 minus plus SO3 2 minus gives Mn2 plus plus SO4 2 minus, and also it is given that it is in the acidic medium. Are you ready to do the balancing? Okay, let us start with them one by one. First, what is the next step? Next, we have to find out the oxidation numbers of each atom. Find out the oxidation numbers of each atom at the top of it and locate the atoms undergoing oxidation and reduction. What you have to do? First, you have to write the skeletal equation, then find out the oxidation numbers of each of the atom present on it, then find out the elements or compounds which is undergoing oxidation and reduction. Then, the third step is that find the change in oxidation number. I will write the equation first here. Okay, what is the first step? First, we have to find out the oxidation number of each atom. So, if we are taking the oxidation number of manganese here, we can given it as plus 7. Right? Then, what about sulfur here? Minus 2 charges total, then plus 6. Right? Minus 2 plus 6, that is equal to plus 4, right? Then, here it is already given plus 2. Again, what about here? Minus 2 plus 8, that is equal to plus 6. Right? We have already find out the oxidation number. Then we have to identify or locate the atoms that is undergoing oxidation and reduction. What is happening here in the case of manganese? It is undergoing reduction, right? Because changing the oxidation number from plus 7 to plus 2. So it is undergoing reduction. Okay, what is the change in oxidation number here? Hi, hello, good evening. What is the change in oxidation number here? In the case of manganese, it is changing from plus 7 to plus 2. What will be the change here? Change by 5, right? What is the change in oxidation number? Here the oxidation number is plus 7. Manganese changing its oxidation number from plus 7 to plus 2, which means they are changing the oxidation number by 5. Clear? Hello Monica. Yes, you can just ask the question. Is it related to this topic or not? Hi Prempal, good evening. Am I audible? Okay, here in the case of reduction, it is changing from +7 to +2, which means change is by 5. Then what about the oxidation here? SO3 is changing from +4 to +6, right? Because the change is by 2. Any doubt there? Is there any doubt how we are calculating the change in oxidation number? Fine. Now we have already found out the change in oxidation number. The next step is that we have to cross multiply the change. We have to cross multiply the change. What do you mean by cross multiplying? Which means that if the reduction is changing by 5, you have just multiplied it with the oxidation. If the oxidation is changing by 2, it should be multiplied with the reduction, right? Clear? For example, I will write it here. Is this step clear for all of you? The last step I have written. Hi Saloni. We are just cross multiplying the change here. Here the +5 change is for the reduction. So I am taking it for the oxidation, right? Here I am multiplying it with the oxidation reaction, that is 5SO3 2 minus gives 5SO4 2 minus. Similarly, here the oxidation change is 2, right? So I multiply with the reduction, that is 2MnO4 minus gives 2Mn plus 2. Is it clear? Now here is the next step. This is our already having the equation. Then we have to find out the balance all the atoms other than oxygen and hydrogen. What are the atoms present here other than hydrogen and oxygen? Which are the atoms present here other than oxygen and hydrogen? One is manganese, right? Manganese and sulfur. So if you are taking here, you can see that 2 manganese present in the left side as well as right side, right? Then what about sulfur? 5 sulfur is present in the left hand side and 5 sulfur is present in the right hand side. Which means the atoms other than oxygen and hydrogen is already balanced here. Clear? It is already balanced. Now what we have to do? Now we have to balance the oxygen atoms by adding a suitable number of water molecules. balance the oxygen atoms by adding suitable number of water molecules at whichever side it is deficient, right? If I am writing here 2 MnO4 minus plus 5 SO3 minus, right? SO3 2 minus gives 2 Mn2 plus 2 Mn2 plus 5 SO4 2 minus. Now we have to balance the number of oxygen atoms. You can see that 2 into 4, 8 oxygen plus 5 into 3, 15. Total, how many oxygens are present here? How many oxygens are present here? In the left hand side, 2 into 4, 8 plus 5 into 3, 15 plus 8. How much it is? 23, right? 23 oxygen atoms are present in the left hand side. Then what about the right hand side? It's only 5 into 4, 20 oxygen. How many oxygen atoms are deficient here in the right hand side? In the product side. Only 3 oxygen, right? 3 oxygen is deficient here. So for that I am adding 3 water molecules to the side where oxygen atom is deficient. So I am adding here 3 water molecules. Now the oxygen atom is balanced. You can see here 5 into 4, 20 oxygen plus 3 oxygen. Total 23 oxygen here. Then what about here? 2 into 4, 8 plus 5 into 3, 15. 15 plus 8, 23 oxygen. Oxygen atom is balanced. Now there is a problem arises that in the product side there will be 6 hydrogen atoms, right? But in the case of reactant side there is no hydrogen atom. So in order to balance the hydrogen atoms, we are adding H plus ions to the required side of the equation. What we are doing to balance the hydrogen atom? We are just adding the required amount of H plus ions to the required side of equation. Clear? Now, in the case of product side, there is 6 hydrogen atoms. So, I am here adding 6 H plus ions to balance the hydrogen atom in the reactant side. Now, you have to check that how many hydrogen atoms are present here. It is already, oxygen is balanced, manganese is also balanced here, then sulfur is also balanced. Now, hydrogen is also balanced here. The next step you have to note that. Okay, the next step you have to note that if the charge is balanced or not. As you can see here, 6 hydrogen, right? Plus 6 charge. Then 2 minus 1, right? Minus 2 charge. Minus 10. How many charges present here? 6 minus 2. 4 minus 10, that is minus 6, right? Then, what about here? 2 into 2, 4 plus 4. Plus 5 into 2 minus 10. That is minus 4 minus 10, that is equal to minus 6, right? Which means charge is also balanced here. Charge is also balanced here. So you can say that this one is the balanced chemical equation or balanced redox reaction for the particular equation, right? Okay. This is the balanced equation. Clear? Hello Tashu. Is it clear for everyone? We have discussed about the oxidation number method by using an example. Clear? This is all about the acidic medium. Then one more point you have to note that if you are taking the reaction is in the basic medium. Reaction is in the basic medium. What will happen? What we have to do that? Follow all the steps in the previous session like the acidic medium. Then what you have to do that? Just add the OH minus ions equal to the number of H plus ions to the both side of the equation. We have to do all the things about the acidic medium. Then just add the equal number of H plus ions, equal number of OH minus ions, same as that to the H plus ion to the both side of the equation. Then you can say that at one side this H plus and OH minus ion pair will act as the water molecule. Then you have to just vanish or the in order to avoid the duplication. All the stoichiometric coefficients in the simplest whole number ratio. I will explain with the example within a basic medium also. No need to worry. Hi Rishabh. Is the thing clear? Now here is a practice question for you. You have to balance these equations according to the oxidation number method. The steps I have already discussed. You have to do the balancing. What is the first step for this? What is the first step for the oxidation number method? Write down the skeletal equation which is already given here. Next, you have to find out the oxidation numbers of each of the atoms. So, I am writing here MnO4 minus plus Fe2 plus, right? Gives Mn2 plus Fe3 plus. Okay, here it is plus 7, right? Then here it is plus 2, here it is plus 2, again plus 3. These are the oxidation number. As you can see here, it is changing its oxidation number from plus 7 to plus 2, right? Plus 7 to plus 2. Which means change by 5. Is there any doubt? Then what about the reduction here? If I am writing here, again, Fe plus 2 is changing from plus 2 to plus 3, right? Which means change by 1. Clear? First you have to write down the skeletal equation for the particular reaction. Then you have to find out the oxidation numbers of each of the atoms present in the reaction. Then find out the one which is having the oxidation and reduction simultaneously. Then find out the change in oxidation number. Then what will be the next step? You have to just cross multiply, right? Cross multiply the change in oxidation numbers. So I am writing the cross multiplying equation here. Is there any doubt in this particular step? I am just cross multiplied the change in oxidation numbers. After writing the equation, you have to first balance the atoms other than hydrogen and oxygen. As you can see here, one is manganese, which is already balanced, right? In both the side, it is only one manganese atom, which is already balanced. Then what about the iron? Here it is 5 iron, here is also 5 iron, which means iron atom is also balanced here. Now we have to balance the oxygen atoms. How many oxygens are present here in the reactant side? Dushyant, hello, good evening. Okay, how many oxygen atoms are present in the left hand side? I mean the reactant side. 4, right? 4 oxygen atoms are present. But in the product side, there is no any oxygen atoms. So we can add that much amount of water molecules. How many water molecules? It is 4 water molecules, right? I'm adding 4 water molecules in order to balance the oxygen atom. Then the next step, you have to balance the hydrogen atom. In the product side, it is 4 into 2, 8 hydrogen atoms are present. Now balance here, you will be adding 8 H plus ions to the reactant side. 8 H plus ions to the reactant side. Clear? Is it clear? Can we move to the next step? So far we have balanced the manganese atoms, iron atoms and hydrogen as well as oxygen. Now we have to check whether the charge is balanced or not. Whether the charge is balanced or not. And one more thing you have to note that in the question it is mentioned that it is in the basic medium. So one more step you have to do that. You have to add the equal number of OH minus ions to the both of the side of the equation. Here 8 H plus ions are present, right? So we are taking 8 OH minus ion to the both side of the equation. So I am writing here in the same side 8 OH minus. Then here it is again 8 OH minus. Then what will happen here? These 8 H plus and 8 OH minus will combine together to form 8 water molecule, right? It will combine together to form 8 water molecule. So I am writing here that is 8H2 plus MnO4 minus plus 5Fe2 plus gives Mn plus 2 5Fe3 plus 4H2O plus 8 OH minus. Is there any doubt? Yes, in this particular case, charge is not balanced because it is in the basic medium. We have to add OH minus ion. That is the issue. Okay. Then you have to just deleting the atoms which is in the similar side or similar numbers. Okay. Here you can see that 8 water molecules are present here in the reactant side. Here it is 4 water molecules. So I am just deleting here from it will become 4 water molecule, right? It will become 4 water molecule. Therefore, the final equation will become 4H2O plus MnO4 minus plus 5Fe2 plus gives Mn2 plus 5Fe3 plus 8 OH minus. Now, whenever you are checking the charge, it is shown that charge is already balanced. You can check here minus 1 plus 10. 10 minus 1, 9, right? Then again 5 into 2. 5 into 3, 15 plus 17 minus 8 again it is 9. Charge is also balanced here. This will be your final balanced chemical redox reaction for this particular reaction in the basic medium. Clear? Is the thing clear for everyone? Just let me know. If it is clear, just give me the thumbs up in the comment box. Yes, fine. Okay, here is the next reaction for you to balance. You can use the oxidation number method. Here, the medium is not specified, so you can take it as the acidic medium. Okay, what is the first step here? First, you have to find out the oxidation numbers, right? What is the oxidation number here? These are the oxidation numbers, right? In H2SO4, sulfur changes its oxidation number plus 6 to minus 2, which means it is undergoing reduction, and the change is equal to how many change? How many numbers are difference here? Change by 8, right? Change by 8. Hi Vinod. Then what about the oxidation here? Okay, here the oxidation is minus 1 to 0. That is for iodine atoms. That is changed by 1. Changed by 1. Then the final point you have to note that here one iodine atom, right? But here it is 2 iodine atoms. So in order to balance this iodine atom, I will put 2 here, which will become 2 Hi gives I2. Clear? Then here you can see that the iodine is changing its minus 1 state to 0 state for only one iodine atom. If you are taking 2 Hi, it will be the change will become 1 into 2, that is equal to 2. Change by 2. Clear? Okay, here is a change, reduction change by 8 and oxidation change by 2. Next step, you have to note that just cross multiplying the change in the oxidation numbers. So I am writing the final equation here. Then one more point noted that if there any possibility to simplify this number, you can change it that, because I am just dividing by 2, it will become change by 4. It will become change by 4. Because I am dividing by this 2, then it will become change by 1. Now we have to cross multiply here 1 into H2SO4 plus 2 into 4, that is 8 Hi, right? 8 Hi gives how many H2S? 1 into H2S, right? H2S plus 4I2. 4I2. Is this clear? This particular step is clear or not? That is H2SO4 plus 8 Hi gives H2S plus 4I2. Next step, you have to note that balance all the atoms other than hydrogen and oxygen. Here it is 1 sulfur, again it is 1 sulfur. It is already balanced. Then what about the iodine atom? Here it is 8 iodine, here it is 402 8 iodine. Iodine atom is also balanced here. Now you have to balance the oxygen atom by adding sufficient amount of water molecule. You can see that here in this case 4 oxygen atoms are present, right? Okay, 4 oxygen atoms are present. Then you can say that you should add 4 water molecules here in order to balance the oxygen atoms, right? 4 water molecules. Then you are checking the number of hydrogen atoms here. Here it is 2 plus 8, 10 hydrogen atom. What about here? 2 hydrogen plus 408 hydrogen, right? Which means hydrogen atom is also balanced here. While checking the charge also, you can see that in the reactor side the whole charge is 0 and the product side is also whole the charge is 0. So you can say that this is a particular balanced redox reaction for this reaction. Clear? Anish, which step you didn't get? What is your doubt? Here I am just giving again about the oxidation number method. In order to find out the balanced redox reaction for the oxidation number method, first you have to do that. Write down the skeletal equation representing the redox reaction. Then find out the oxidation numbers of each of the atoms present in the particular reaction. Then find out which one is undergoing reduction and oxidation. Then what you have to note that this step is very important because you have to find out the change in oxidation number there. Change in oxidation number there. Then by finding the change in oxidation number, you have to just cross multiply the change. Which means if you have a change X in the case of reduction, you will multiply it with the oxidation reaction. Then similarly to the reduction reaction also. Clear? Then next step, you have to balance all the atoms other than oxygen and hydrogen. While balancing there, you have to balance the oxygen atom by adding sufficient amount of water molecules to the side where the oxygen atom is deficient. Then one more point you have to note that if the reaction is in the acidic medium, you can balance the hydrogen atoms by adding H plus ions. If the reaction is in the basic medium, you must add OH minus ions to the both sides of the equation. Clear? Dushyant, right? What is your doubt? Okay, now let me move to the second type of method, that is the half reaction method. I hope the oxidation number method was clear for everyone. Now let me move to the next method, that is half reaction method. In the oxidation number method, we are considering the change in oxidation number, right? But here we are considering the charges or the number of electrons. Therefore, the half reaction method is also known as ion-electron method. It is also known as ion-electron method. You can see that these are the major steps while doing the balancing according to half reaction method. We can see one by one. Same as that of the oxidation number. First write down the skeletal equation representing the redox reaction. First write down the skeletal equation representing the redox reaction. Then find out the same step. Find out the oxidation numbers of each of the atom at the top of it in the equation. Then here you have to take that half reaction, right? You have to split this whole reaction into two halves. One is oxidation half and second one is reduction half. Split the reaction into two halves. One is oxidation half and another one is reduction half. Then you have to do that separately. Balance each of the half reactions separately by this method. Dushyant, what is your doubt? Just give me the doubt, then only I can explain. Fine. How we can balance the half reaction separately? There are again one more steps. The first step is balance the atoms other than hydrogen and oxygen. Same as that of the oxidation number method. Then balance the oxygen atoms by adding required number of water molecules to the side where oxygen atom is deficient. Then if the medium is in the acidic medium, same as that of the oxidation number method, to balance the hydrogen atom, you are adding the required number of H plus ions, right? Same as the oxidation number method. Then what about here the major point you have to note that after balancing all the atoms other than hydrogen and oxygen, then balancing hydrogen and oxygen atoms, you have to balance the charges also. In order to balance the charge, you have to do some addition of the electrons. What you have to do? Add required number of electrons to balance the charges. No need to worry, I will explain. I will explain all these rules along with the examples. I'm just giving you a brief explanation about the half reaction method. Okay, you have to balance the charge by adding the required number of electrons. Then what you have to do? Just equalize the number of electrons in the two half reactions. Just equalize the number of electrons in the two half reactions by multiplying the same integer or required number. Okay. Then, in order to get to the final equation, what you have to do that? The basics of this reaction method is that the total number of electrons lost by the oxidation should be equal to the total number of electrons gained by the reduction, right? Electrons should be same. So that add the two reactions to get the final equation. We have already oxidation half and reduction half, right? So we are just adding the two half reactions to get the final equation, which has no free electrons on either side and is balanced in terms of atoms as well as charges. Clear? Now, here also two mediums are present. If the acidic medium is present, you can add H plus ions to balance the hydrogen atom. But if the basic medium is present, you just add the number of hydroxyl ion equal to the number of H plus ions to the both side of the equation. Same as that of the previous method, right? Then write out the H plus OH main pair as water molecule. Clear? Clear? Can we move to the example? Here is the example for you. The reaction is given here. You have to balance this particular reaction according to half reaction method. What is the first step given here? First, you have to write out the skeletal equation here. Then find out the oxidation numbers. As you can see here, in the case of Fe2+, the oxidation number is +2, right? Then what about Cr2O7 2-? +6, right? Then here it is +3. Again it is +3. You can see here Fe is changing its oxidation number from +2 to +3, which means it is undergoing oxidation. It is undergoing oxidation. Then what about here? Cr2O7 2- gives Cr3+, which means it's changing its oxidation number from +6 to +3, that is reduction. +6 to +3, it is reduction. Now you have to split this whole reaction into two half reactions. That is, one is oxidation half and another one is reduction half. I will write down here which one will be your oxidation half. What is the oxidation half here? Cr2O7 2- gives Cr3+, right? So I am writing here Cr2O7 2- gives Cr3+. This is our oxidation half. Now what you have to do that? First you have to balance all the atoms other than hydrogen and oxygen here. As you can see here in this side, there is two chromium atoms, right? Two chromium atoms are present. But here there is only one chromium, so I am just putting 2 here. 2 Cr plus 3. 2 Cr plus 3. Then what you have to do that? First you have to balance the oxygen atoms. Here it is 7 oxygen atoms are present, right? 7 oxygen atoms. Here deficient of 7 oxygen atoms are present, so I am adding 7 water molecules. Any doubt? In order to balance the oxygen atom, I am adding the sufficient amount of water molecules to the side where the oxygen atom is deficient. Clear? Okay, here you can see that 7 into 2, 14 hydrogen atoms are present here, but there is no any hydrogen atoms, so I am just adding 14H plus here in this side. 14H plus plus. Okay, 14H plus plus. Cr2O7 2 minus gives 2Cr3 plus plus 7H2. So far we have balanced the hydrogen atoms, water molecules, hydrogen atoms, oxygen atoms, chromium, and yes, all the atoms are balanced here, right? Fine. Now the next step you have to add that we have to check whether the charge is balanced or not. Whether the charge is balanced or not. What is the total charge here? What is the total charge here? 14 plus minus 2, right? Plus 12 charge is present here. Then what about here? 2 into 3 plus 0, that is 6 plus 6 charge, right? The most important point you have to note that in order to balance the charge, you have just add the number of electrons to the side where maximum positive charge is present. Where maximum positive charge is present. As you can see here, it is plus 12 and here it is plus 6. So I am just adding here. I am adding 6 electron here. 6 electron in order to balance the charge. Now charge is balanced here, right? Here it is 14 minus 2, 12 minus 6 plus 6. Again 2 into plus 3 plus 6. Charge is also balanced here. This is about the oxidation half. Similarly, you have to do balancing on the reduction half also. Okay, I will write here. This is our oxidation half. This is the first equation, right? Then, what about the reduction half? Reduction half is Fe2 plus gives Fe3 plus, right? Fe2 plus gives Fe3 plus. That is, there is no any hydrogen atom or oxygen atom. No need to balance the hydrogen and oxygen. Already iron is present here, which is already balanced, right? So we have to just add the charge only. Here it is plus 2, here it is plus 3. In order to balance the charge by adding number of electrons, first add the number of electrons to the side where the maximum positive charge is present. As you can see here, plus 3 is the maximum here. So I am adding 1 electron here. Clear? Is the step is clear? Fine. Now this important point noted that the total number of electrons should be equal, right? Here you can see that in the case of oxidation half, it is 6 electron, but in the case of reduction half, it is only 1 electron, right? So in order to maintain the number of electrons same, I am just multiplying this equation with 6. Is there any problem? I am just multiplying here, so you can get the final equation is equal to 6 Fe2 plus 2 plus gives 6 Fe3 plus 6 electron. This will be our final reduction half reaction. Clear? We have already balanced the oxidation half reaction here. Then this is the reduction half reaction balanced one. Now we have to do that, add these two half reactions. So I am just adding here. This is our oxidation half, that is 6 electron plus 14 H plus Cr2O7 2 minus plus 6 Fe2 plus, right? Plus 6 Fe2 plus gives 2 Cr3 plus plus 7H2O plus 6Fe3 plus 6 electron. 6Fe3 plus 6 electron. Now you can see here, same number of electrons are present in the both of the side, so we can cancel it. 6 electron get cancelled, which means 14H plus Cr2O7 2 minus plus 6Fe2 plus gives 2Cr3 plus 7H2O plus 6Fe3 plus. This will be our final balanced chemical redox reaction, balanced chemical equation for the redox reaction. Clear? You have to just check the charge also. 14 minus 2, 12. 12 plus 12, 0, right? Again, 2 into, yes, 2 into 3, 6. 6 plus 18, 24. Yes, 24, right. 6 into 2, 12. Minus 2, 10. Plus 14, yes, 24 charge, right? Clear? Is it clear? Now here is the next question for you. Here is the next question for you. The question is, permanganate ion MnO4 minus in basic solution oxidizes iodide ion I minus to produce molecular iodine and manganese 4 oxide. Write a balanced ionic equation to represent this redox reaction. The reaction is given in words. You have to find out the chemical reaction, the skeletal equation, and you have to balance it accordingly. Okay, this is a little bit tough topic, but if the concept is clear, it will be very fine. You can score maximum marks from this topic. This is a most repeated topic from the redox reaction. Okay, what is the reaction here? Hi Sakshi, what is the reaction here? It is permanganate ion, right? So I am writing here MnO4 minus in basic solution oxidizes iodide ion. Iodide ion means I minus, already given in the question. Iodide ion gives molecular iodine, that is I2, plus manganese oxide, which is given here MnO2. Then the benefit of this question is that you don't want to calculate the oxidation number here, which is already given here. For permanganate ion, this is plus 7. Then for iodine, it is minus 1. Iodide ion, it is minus 1. For iodine, it is 0. Then for manganese oxide, right, MnO2, it is plus 4. Now you have to do the separate half reactions accordingly, oxidation half and reduction half. So you can see here manganese changing its oxidation number from plus 7 to plus 4, which means it is undergoing reduction. So I am writing the reduction half here. Okay, what is the reduction half here? MnO4 minus gives MnO2, right? This is the reduction half. Then the next step, you have to balance the atoms other than hydrogen and oxygen. Here only manganese is present. In the both the side, it is only one manganese, which is already balanced. Then the next step, you have to balance the oxygen atom by adding sufficient amount of water. Here you can see that four oxygen atoms are present in the reactant side, but in the case of product side, it is only 2 oxygen. So I am adding, how many water molecules I want to add here? Anyone? How many water molecules you have to add in the product side? That is the question. Yes, 2, right? 2 water molecules are adding here. Yes, fine. Now, what is the problem here? Here it is 4 hydrogen atoms present, but in the case of here, it is only, there is no any hydrogen atoms, so I am adding 4 H plus ions here. 4 H plus ions here. Is there any doubt? In order to balance the hydrogen atom, I am just adding 4 H plus ions to the reactant side. So far, all the atoms including manganese, oxygen and hydrogen is balanced here. Now, what do you have to do? You have to balance the charge, right? Here it is 4 minus 1, that is plus 3. Then what about here? It is only 0, right? There is a point that whenever you have to balance the charge, you just add the sufficient amount of electrons to the side where the maximum positive charge is present. So you can see here, it is plus 3 and it is 0, right? Which is the maximum one, plus 3. So we are adding how many number of electrons? 3 number of electrons, right? 3 electrons are adding to the left hand side. So I am writing here 3 electron plus 4H plus MnO4 minus gives MnO2 plus 2H2O. 2H2O. This will be the balanced equation for the reduction half. So I am taking here equation 1. Clear? Similarly, you have to do the balancing according to the oxidation half also. I will write the oxidation half here. Which is the oxidation reaction here? Which is the oxidation reaction here? I minus is changing from minus 1 to 0, right? I minus gives I2. I minus gives I2. First step, you have to balance the atoms other than hydrogen and oxygen. Here only iodine is present. In the reactant side, it is only 1 iodine. So, in the product side, it is 2. So, I am putting 2 here, which means 2 I minus gives I2. So far, iodine is balanced here. Then, there is no any hydrogen atom, no any oxygen atom. So, no need to balance the hydrogen and oxygen here. Then, what is the next step? You have to balance the charge, right? Here it is minus 2, here it is 0. Which one is the maximum positive number? Minus 2 or 0? Minus 2 or 0? Zero, right? 0 is the positive number. Not positive number, it is greater than the minus 2. So, I am just adding 2 electrons to this side. 2 electrons to the side. Finally, we got the oxidation half reaction. Balance the oxidation half reaction. Now, you can see here, it is 3 electron, right? In the case of reduction half, it is 3 electron. But in the case of oxidation half, it is 2 electron. So, you have to just make the similar number of electrons here. So, I am just multiplying this whole equation with 3. Is there any problem? I am just multiplying with 3. So, it will become, how much it will become? 3 into 2, 6i minus, right? 6i minus gives 3i2 plus 6 electron. Clear? Then now I am multiplying this equation with the 2 in order to make the 3 electron into 6 electron, right? So it will become 6 electron plus 2 into 4, 8h plus 2 MnO4 minus gives 2 MnO2 plus 2H2O plus 2H2O. Clear? This will be the reduction half. Now I am just adding the oxidation half and reduction half. You will get 6I minus plus 8H plus 2MnO4 minus. Okay, this will be the final redox reaction here. As you can see here, 6 electrons are common here, right? So I am just deleting the 6 electrons from both of the sides. Then it will become 6I minus plus 8H plus 2MnO4 minus gives 3I2 plus 2MnO2 plus 2H2. Here in the question it is mentioned that the solution is in the basic medium. Solution is in the basic medium. So we have to add similar number of OH minus to both of the sides. So I am just adding here 6I minus plus 8H plus 8OH minus, right? 8H plus 8OH minus plus 2MnO4 minus gives 3I2 plus 2MnO2 plus 2H2O plus OH minus, right? 8 OH minus. Okay, what will happen here? These 8 H plus and 8 OH minus combine together to form 8 water molecule, right? 8 water molecule. Then it will become, here it is 8 water molecule, here it is 2 water molecule. So I am just deleting those 2 water molecules from here. Then final equation will become 6I minus plus 6 water molecule, right? 8 minus 2, 6 water molecule plus 2MnO4 minus gives 3I2 plus 2MnO2 plus 8 OH minus. This will be the final balanced redox reaction for the particular reaction in the basic medium. Clear? Is the steps clear for everyone? As you can check here whether the final equation is correct or not. Here it is 6 iodine, right? Here is also 3 into 2, 6 iodine. Then 6 into 2, 12 hydrogen. Here it is there is a small mistake, right? Six into 2, 12. Here it is 8 hydrogen, right? Then what about oxygen? 6 oxygen plus 2 into 4, 8. 8 plus 6, 14. 2 into 2, 4. 14, right? Okay, this will be the 4. Okay, what is the mistake here? Yes, this is the mistake. Here it will be 4H2O. Because we are multiplying with the 2, right? It will become 4H2O. Then finally here it is also Then finally here it is become 4H2. Then the final balanced equation will get. Again you can just check here 4 into 2 8 hydrogen. Here is also 8 hydrogen. Then 2 into 4 8 oxygen. Here it is 8 oxygen. Manganese is also balanced here. This will be the final balanced chemical equation for this particular reaction. Clear? Is it clear? Okay, here we have discussed about the balancing of redox reaction by using oxidation number method as well as half reaction method. Here is the one practice question for you. Just find out the number of, what is the value of n here? Find the value of n in the following equation if balanced. What is the answer here? Okay, this is the balanced equation. So you can say that charge should be balanced, right? So if you are finding the charge here it is minus 2 plus 14 plus 2n, right? 2n, and we have to find out. That is equal to 2 into 3 6 plus 3n plus 0, right? So whenever we are adding here 14 minus 2 it is 12 plus 2n is equal to 6 plus 3n. Or you can say that 3n minus 2n, n is equal to 12 minus 6, that is equal to 6. Which means option 4 will be the correct answer. Clear? Option 4 will be the correct answer. Again here is the next question. Find out the value of n in this particular reaction. Just given here MnO4 minus plus 8H plus plus n electron gives Mn plus 2 plus 4H2. What will be the number of electrons present over here? Yes, Anish, you are correct. What will be the answer here? MnO4 minus plus 8H plus plus n electron gives Mn2 plus plus 4H2. Again, you have to find out the charge here. The total charge is here minus 1 plus 8 plus minus n, right? Electron having charge of minus 1. If n electrons are there, it is equal to minus n. That is equal to plus 2, right? By calculating here, you will get 8 minus 1 is equal to 6. 6 minus n is equal to 2, or n is equal to 4. Clear? If there is some mistake in the calculation part, the answer will be 5 only. Clear? Okay, I have few more questions here. I think our time has already finished. 1 hour is finished here. Okay, these questions are based on the balancing of the redox reaction. Okay, just note it down this question here and find out the answer in the comment box or tomorrow's session. Just give me the answer in the tomorrow session. Here the reaction is given. How many number of OH minus ions are appearing in the given balanced equation? The question is noted or not? Okay, so far we discussed the balancing of redox reaction using oxidation number method and half reaction method. I hope it was clear for everyone. Then tomorrow onwards, next session we will be discussing about the redox titration. So far we have discussed about the balancing of redox reaction as well as the basics of redox reaction. Then by tomorrow, day after tomorrow, we will just finish this chapter, redox reaction. Okay, there is a general reminder for you. This Infinity Learn is providing an all India test series for JEE Main Session 2 and JEE Advanced 2025. Then there is a special discount for you. Actual price is 5,999, but you will get this special offer around 2,999 using this code YouTube 50 off. Don't miss this opportunity. Okay, that's all from my side for today. I hope you guys have enjoyed the session or you have cleared all the doubts about the balancing of redox reaction. Then thank you so much. Don't forget to subscribe our channel. Hit the like button as well as share this particular session to your friends and family also. And thank you so much. Good night all of you. Bye bye. Take care.